Hello dear students, welcome back to your math classes. How are you all? I hope you all are good and doing well. So students, I'm your mathematics educator again here with a new chapter and a new concept. And today we have chapter number 9, which is basic geometrical concept. So in this chapter we are going to deal with the basic concept we have to use while we study about the geometrical concept. So let's get started. So the word geometry comes from two ancient Greek words, geo meaning the earth and metra meaning the measure. So we are going to, so literally geometry means to measure the earth. So geometry was extremely important to ancient societies and was used for surveying, astronomy, navigation and construction. Geometry as we know it today is Euclidean geometry, which was written well over 2000 years ago in Greece by Euclid, Pythagoras, Thales, Plato and Aristotle, just to mention a few. So over time, geometry has become a body of knowledge that let us go from knowing certain things about a figure to predicting other things about with it certain. So what we do here, where geometry is a Greek word and geo means geometry is originated with Greek words where geo means earth and metra means measure. So we already do what we are doing to deal with the measurements of the earth. And now we are this concept is written before 2000 years ago, and now we are going to deal with it. So in this chapter you will learn about. So what we have to learn in this chapter is it we have to measure the earth? No, we have to deal with the basic concept of geometry, which is point, plane and line, and the foundation stones of geometry. You will also know about the angles and closed figures. So this is the gist which we do in art. So this is the concept we have to learn in this class. So first of all we have point. Point is a single dot. So this dot A, this dot B, this dot C is represented as your point. And point has no length, no width and no height. It is a zero dimensional. Therefore, you cannot actually draw a point. You can only represent a point using a dot like this. So this is a point you have. Now corners of paper, tip of cone, pointed end of a needle are examples of the points. Now we have plane. A plane is a flat surface which extends indefinitely in all directions. Looking around your classroom, you can immediately get the idea of plane. Surface of walls, floors, ceiling, sheet of papers, etc. Since a plane extends indefinitely in all directions, it cannot be drawn on paper. Only a portion of plane is shown by means of a rectangle parallelogram. So the shapes you have in your classroom, the figures you made on your papers like rectangle, square, these are the examples of the plane you have. Now we have line. So line is a collection of points extending indefinitely in both directions. So this is your line, and we have two arrows in line which we can extend in both the direction indefinitely. And how can we represent our line? By labeling it A and B and with a arrow. A line with both the sides arrows we have. Next we have line segment. In example that we consider above, we get part of line. The part of a line, two definite ends points, it's called a line segment. So in line segment we have a starting point and an ending point. In line we don't have a starting point and end point. We can extend it indefinitely, but in line segment we have a definite measurement basically. Okay, so there is only one line segment determine two given points. Since a line is an extension of line segment, only one line can be drawn passing through two given points in a plane. Thus, through a given point O, infinitely many lines can be drawn. So, in a point O, we can make a indefinitely lines. So, now we have collinear points. Three or more points are said to be collinear if they all lie on the same line. When the two points do not lie on a same line, they are called non-collinear points. So, what you notice here, we have points on a single line, on a straight line in the same direction. Point A, point C, point D and point. So these are your collinear, yani ki in a same line we have. So collinear points we have, but those are not in line in a single line. So those are your non-collinear points. For example, A and B are collinear, but this point C is not collinear. So that is called non-collinear points. Now we have congruent lines. Three or more lines are said to be congruent if they all pass through a common point. For example, your point, for example, line L1, L2, L3, L4, all these four lines are passed through to the point O. That's why they are called congruent lines. Now we have a pair of lines. So first of all, we have intersecting line. When two lines are crossing out each other, that is called your intersecting lines. So consider two lines L and M shown in the figure. Point P lies on both the lines L and M. Two lines passing through a common point are called intersecting line, and the common point, it's called the point of intersection. So this point P is called point of intersection, and line L and M are intersecting to each other. Next, we have parallel lines. If a pair of lines do not intersect, then we say that the lines are parallel. Two parallel lines do not have a common point. So, for example, in alphabet E, if we see L and M, line L and M are never cross out each other. That's why these two lines are parallel to each other. Here you can see that opposite edges of a rural. These are two lines we have which are never cross out to each other. And one more thing, in parallel lines we have equal distance between the two lines. Okay, now we have to read out about the ray. A ray is a part of a line which extends indefinitely in one direction from a fixed point, say O. So O is called the initial point of the ray. Thus A ray has one endpoint, light emitted by the sun is physical example of rays. Similarly, light emitted by an electric bulb is an example of rays. So what we notice here, that when we have a arrow only a single side, okay, only we have a starting point but not an ending point, that is called a ray. And how can we represent it? By labeling it A and B, and an arrow only one side. So we have three types of lines till now which we understood. The first one, line where we have arrows on both the sides. Next we have line segment where we have a starting point and ending point, we cannot extend it indefinitely. And then we have ray where we have only a one point, a starting point only, and there is a no end point, and we can extend it in one direction indefinitely. So I hope so these three are clear to you. Now name 4 points and 4 line segments in the adjacent figure. So 4 points in the given figure are A, B, C, D, and in the line segments are A, B, B, C, C, A, and A, D. Now name three. For the given figure, write all parallel lines, pairs of parallel lines, all pairs of intersecting line collinear points. So L is parallel to M is parallel to N, and line AC is cross out the line AC. Wait. So pairs of parallel lines are L, M is parallel MN, and LN, and pairs of intersecting lines are AD, AC, BE, BC, CF. Now we have our exercise 9.1. From the given figure, name 3 points. So 3 points we have A, O, and D. So now we have our exercise 9.1 where we have to write and where we have to mention 3 lines, 3 points. So we have A, B, and D points. Now you have to mention the 2 rays. So you can take rays A, B, C, D. 3 line segments we have BC, OP, like this. 2 lines we have to. So you have line AB and CD. Now use the given figure. So same you have to do in question number 2, question number 3, in question number 4, where you have to mention rays, points, and line segments and collinear points. From the given figure, all rays with the initial point A. So initial point A and all rays. So you have AH and AD, and you can also say AB, AC. These are also your rays which initial point is A. Now all rays with initial point D. So here you can say DE and DC. These are the pairs. 2 pairs of intersecting lines we have DH, and you can say CF. DH and CF. 2 pairs of parallel lines we have AH and BG. Concurrent lines where we have lines which we are crossing to a particular point. So DE or DE and HD are those points. Line segments with one end point C collinear points. So rest of the parts you can mention it here because you know all the concept which we already do in our earlier section. So you can simply write your collinear points, line segments with the one end point C. So line segments with one end point C we have CF. Collinear points we have A, B, C, and D. Is Ray CB same as ray CA. C, B and C, A. We can say that because in both the cases the initial point is C, so you can explain it. Now classify the following statements as true and false. A point has no length, width or height. Yes, this is true. Infinite or numbers of lines can be drawn passing through two given points. Two given points we cannot say, but one given point we can say yes. Through a given point only one line can be drawn. No, false. So in same way you have to read out these statements and then you have to classify among true and false statements. Okay. After this we have curves. So take a piece of paper without lifting in between, move the tip of pencil. So when we curves means a starting point and the ending points is differ. We have 2 points, starting point and ending point. In closed figure we start from a single point. Curves which begin and end at the same point are called closed figures. So these are the examples of closed figures. Open figures, again we have a starting point and an ending point too. So curves which do not begin and end at the same point are called curved, are called open curves. For example, these are the example of open curves. So you can easily classify between closed figures and open curves. After this you have simple curves. Curves which do not cross themselves are called simple curves. So in this curves what you notice, these are not cross out themselves, so these are called your simple curves. Closed figures which do not cross themselves are called simple closed figures. For example, these are the example of your simple closed figures. The following curves are not simple because these are crossing out themselves, right? So these are not simple curves. Now interior and exterior of a closed figure. So if on a plane a closed curve is drawn, it divides the plane in three parts: interior of the curve, boundary of the curve and exterior outside of the curve. So here this is the boundary of the curve, this portion is inside of the curve and this point Q is exterior of the curve. After this we have polygon. For polygons are simple closed curves made up of line segments only. So your triangle, polygons are simple closed curves made up of line segments only. So when we make figures which is made only with the help of line segments, that is called your polygon. For example, you may know that in a polygon any pair of line segments which are intersecting are doing so that at their end points the adjacent figures are closed curves but not polygons. These are not polygons because these are closed figures but not polygons. Why? Because in this we are using curves, and when in polygons we have to use only line segments to form a shape. Now we have terms related to polygon. First of all we have side. So these are the sides of a polygon. For example, DE, DC, CB. So the line segments forming a polygon are called its sides. Now we have vertex. So the points, the corners we have. So the point of intersection of a pair of side of a polygon, it's called its vertex. The polygon shown above has 5 vertex: D, C, B, A, E. These are the vertex we have. Then we have diagonals. If you join two adjacent vertex, you get a side of the polygon. So then your D and A is a diagonal, E and C is a diagonal, D and B is a diagonal. So wait. If you join two adjacent vertex, you get a side of a polygon. So we have to join two adjacent vertex of a angle and two adjacent vertex of a if you join two adjacent vertex, you get a okay. So here what you have to do, you have to join two adjacent vertices, so you will get a diagonal of that polygon. Now we have our exercise 9.2. So which of the followings are curve? Open curves. So starting point and ending point are different. So it is an example of open curve. Closed figure where we have a same starting and ending point. So you can say that it is a students is an example of your open curves and closed figures. Now you have to solve your own both among simple curves, simple open curves and simple closed curve for rest of the following figures you have. For the given figure, name points in the interior of the closed figure. So interior in the closed figures we have point B and A. Points in the exterior of the closed figure, so we have point C and E. That is very simple. The points which lie inside the figure, that is your interior points. Which lie outside of the figure, that is your outside points. Points on the closed figure. So on the closed figures we have E. So for here you can rub it. Here we have only one point outside of the figure. So here we have D also on the boundary. Draw a polygon having four sides, name its side, vertex and diagonal. So you can make a square and you label it A, B, C, D. So your vertex will be, if you make a square A, B, C, D, your vertex will be A, B, C and D. Your sides will be AB, BC, CD and DA. After this, for the given polygon, name adjacent sides and adjacent vertex and diagonals. So adjacent vertex are F and A, where we have a same line. For example, same vertex A is a common vertex for AB and AF. So these are your adjacent sides, AF and AB. And adjacent vertex are also A and B. And now you can also write your diagonals which are adjacent. So AD and FB. So these are your diagonals. Now sketch three closed figures which are not polygons. So that is very easy. You can do it yourself. So next concept we have angle. The word angle comes from the Latin word angulus, meaning a corner. So forming an angle we have to use two rays, and when we have a common vertex in two rays, this is the formation of our angle, and you can make an angle like this also. So formation of a corner gives an angle. If you have a look at your surroundings, you can have an idea of an angle. Have a look at two hands of a clock, two blades of a pair of scissors, an inclined ladder resting against a wall, adjacent sides of shape. So an angle is a figure formed by two rays with the same initial point. So in this BO and OA row, we have a common initial point which is O. So BOA is our angle. Now O is the vertex of OA and OB, and OB are the arms of the angle. To show an angle, a small curve is marked at the vertex. The symbol this is a symbol of angle. It's used to denote an angle. Now interior and exterior of angle. Consider angle POQ. POQ divides the surface of the paper in three parts. QOP. So this is your angle. Now part of the plane lying within the arms of the angle produce indefinitely called interior of the angle. So this is your interior of the angle. Arms of the angle, part of the plane. So OQ and OP are the arms of your angle. Part of the plane lying outside the arms of the angle produce indefinitely called exterior of the angle. So this point F are the exterior of the angle. Now we have our exercise 9.3. Name the angles in the given figure. So COB, angle symbol COB. After this again angle symbol BOA. So these are the two angles we have in figure. Now name the angles in the polygon. So DEA, DEA, DCB, and rest of the angles you have to mention it your own. In the adjoining figure, name the points in the interior of angle AOC. So in the anterior angle of AOC, G, B is also interior the AOC. You can mention B and D as well. In the exterior of BOC, BOC, the exterior of BC, we have E. On angle AOB, AOB. So we have B and D. Now we have a triangle. A triangle is a polygon with three sides. Putting it in a simple way, a triangle is a closed figure bounded by three line segments. If you join any three known collinear points pairwise, you will get a triangle. So you have three known collinear points A, B and C, and if you join them together with pairwise, so you will get a triangle. So as for a polygon, a triangle has an interior and an exterior. The region enclosed by the sides of a triangle, it's called the interior of the triangle, and the interior of the triangle together with the triangle form the triangular region. So this is your triangular region which is lie inside the triangle. Next we have our exercise 9.4. Name the triangle in the following figures. So in this we have triangle ABD. We have to form a symbol of triangle B, D and triangle ADC. For next figure, you have to write the names of the triangle you own. Now draw a triangle and name all its parts. So we can form a triangle A, B and C. A, B and C are the vertex of this triangle. AB, BC and CA are the sides. Okay. For the given figure, name points in the exterior of triangle ABD. So ABT, inside of it we can say G, but we cannot because it is lie on boundary of it. Points in the interior of triangle ABC. So we can say G. Points in the triangular region of triangle ABC. So points we have G, F. So these are the points you have inside the region of triangle ABC. Now we have our quadrilateral. Quadrilateral is a polygon with four sides, or in other words a simple closed curve bounded by four line segments. So in a previous section we learned about the triangle where we have three line segments, and here we have four line segments to form a quadrilateral. So 1, 2, 3, 4. A quadrilateral has four sides, four vertex and four angles. In the quadrilateral given above, the four sides AB, BC, CD and DE. The four vertex are A, B, C and D. The four angle are angle BAD. So you know how you can mention your angles. So your angle DAB, ABC, CDA. So in that way you can easily mention your triangles. Two angles of a quadrilateral having a common arm called adjacent angles. In quadrilateral ABCD, pair of adjacent angles are angle A and angle B. So in quadrilateral ABCD, we have adjacent angles, angle A, angle B, angle D, angle C, and two angles of a quadrilateral which are not adjacent, which do not have a common arm, are called opposite angles. In quadrilateral ABCD, pairs of opposite angles are equal. So what we understand here, opposite sides are equal, adjacent angles are equal, and opposite angles are also equal, and a quadrilateral together with its interior forms of a quadrilateral region. So this is your quadrilateral region, which is boundary, which is lie inside the sides of AB, BC, CD and DA. Now we have our exercise 9.5. Name the quadrilateral in the figure. So here we have quadrilateral B, D, E, F. Similarly, you can write other quadrilateral as well, F, D, C, E, or you can A, F, D, E. So you have to identify it and write the name of the quadrilateral. In the given quadrilateral, name a pair of adjacent side. Adjacent side where we have a common vertex. So CF and CD are the adjacent side. Adjacent vertex. So you have C and F. Opposite sides EF and CD. Opposite angles, angle C and angle E. Adjacent angles, angle, we have a common arms and common vertex. So angle FCD and angle CFD. Diagonals are FD and EC. Now for the given figure, name points in the this question is very easy. You just have to write your points which is like inside the figure, outside the figure and on the quadrilateral region. So you have to do it your own. Next we have a circle. So till now you have studied closed figures made up of straight lines. In this section you will learn about a closed curve not formed by a straight line. So now we have a figure which is not formed by a line segment, it is formed by a curve. So the figure is that of a circle. If you look around, you will see many things in your surrounding which will give you an idea of circle. A bangle, a wheel, a ring, a coin or a plate. So you remember that song which we do when we small, Mummy ki roti gol gol, Papa ka chashma gol gol. So that is linked with your circle. Now what are the parts we have in a circle? So the first thing we have, that is your center. The fixed point, it's called center of the circle, and the fixed distance is called the radius of the circle. So I hope so you have your equipments, your compass. So when you place your compass to a particular, your pin, compass pin is placed at a particular fixed point, that is called your center. This point O is your center, and the distance from O to P, right? The distance, if your teacher tell you you have to make 2 centimeter circle, so you open your compass from 0 to 2. So 2 is your radius. So the distance from 0 to P is called your radius. The figure shows a circle with center O and 2 radii, plural of radius. OP and OQ. Take a point A on the circle, join O and A. O is another radius of the circle. Now we have diameter. When a line is passed through the point A, passed through your center, that is called your diameter. A line segment passing through the center of a circle and having its end points on the circle, it's called a diameter of the circle. And what is the relationship between diameter and radius? Your diameter is equal to twice of radius. Now we have chord of a circle. So chord of a circle, a line in which we have to make in our circle, which is not passing through your center. So what you see, this line is not passing through your center. The biggest chord we have, that is your diameter, which is passes through the center. A line segment with its end point on a circle, it's called the chord of a circle. A diameter is a chord passing through the center of the circle. Now arc of a circle is a small portion of a circle, it's called the arc. 2 points P and Q divide the circle in two parts called arcs. An arc is a portion of a circle of the two parts of a circle determined by the points P and Q. The smaller part it's called minor arc and the greater part it's called major arc. So this is your minor arc and this is your major arc. Okay. So a diameter of a circle divides the circle in two equal parts, arcs, each part called a semicircle in the figure. So when we form a diameter, so what we see, a circle is divided into two equal parts and that two equal parts called semicircles. Now interior and exterior of a circle, so same concept which we learned till now, that the portion that lie inside your circle, that is called your interior part, and which lie outside of the circle, that is called your outside of the part. So being a closed curve, a circle has an interior and exterior. The part of the plane inside the circle is called interior of the circle. The part of the plane outside the circle, it's called exterior of the circle. The circle together with its interior, it's called the circular region. And when you form your chord now, so for example, this is your chord AB. So the portion covered by chord, it's called minor segment, and the portion left by the chord, it's called major segment. And you can also relate it with your pizza. When you form your triangular parts, that is called a particular region. The segment containing the minor arc, it's called minor segment, and the segment containing major arc, it's called major segment. A diameter divides the circle region into two parts. Each part, it's called a semicircle region. A region in the interior of the circle enclosed by an arc and a portion of radii, it's called a sector. The sector having minor arc as a part of its boundary, it's called minor. जो segment वाला part था ना, इसे काट देना पिज्जा वाले उससे और यहाँ से दोबारा से start करना. Where you have to relate your sector, where when you joined your two radii with the radii together. For example, like this. So this is your minor sector and the left portion is your major sector. Now we have our exercise 9.6. For the given circle, name the following parts. Our diameter is PQ. Our center is O. Two radii we have OA and OB. A chord will be, we have BQ. A major arc will be, we can say PAQ. A minor arc will be AB. Okay. For each of the following statements, state true or false. The diameter of a circle is twice of radius. Yes, this is true. A radius of a circle is a chord of the circle. No, this is false. The centers of the circle is a point of a circle. Yes, we can know. You can say that, but not properly. An arc is a part of the circle. Yes, true. So now you have to read out these statements and then you have to classify these statements into true or false. Filling the blanks with appropriate words. A line segment joining 2 points on a circle, it's called a line segment joining a 2 points on a circle called a chord as well as a diameter. The distance around a circle, it's called its circumference. The radius of a circle is twice of its diameter. So students, you have to fill the rest of the blanks left by me in the question number 3, your own, And after this is the end of your chapter, and here you have the things you have to keep in your mind. If you forget any concept, you can go there. Here you have a combined form of your concept which we learned till now. Now I'm going to meet you in your next class with a new chapter and a new concept. So students, till that, bye bye, have a good day.